Part 4 says using reference angles to evaluate trigonometric functions. Okay, this first statement is very important as far as helping you work out the examples that go along with this section. It says the values of the trigonometric functions of a given angle theta are the same as the values of the trigonometric functions of the reference angle theta prime, except possibly for the sine. Okay, so the value of a trigonometric function of any angle theta is found as follows. First, you're going to find the associated reference angle, just like we were doing on the previous section, and then find the function value for that angle. Use the quadrant in which theta lies to prefix the appropriate sign to the function value. Okay, so I just have written on here, just to kind of help you remember, all of our trig functions are positive in the first quadrant. Sine and its reciprocal would be positive in the second quadrant, tangent in the third, and cosine in the fourth quadrant. Okay, so the directions will say use the reference angles to find the exact value of each of the following trig functions. So we want to find the sine of 135 degrees. Okay, if it says exact value in my math lab, then you can't type in a decimal. Okay, they want the exact value. Okay, it may contain a radical or it may not, it just depends. Okay, so if I have a non-acute angle, I want to find the reference angle. So my reference angle for 135 degrees would be to subtract 135 from 180. So that gives me 45 degrees. Okay, so the sine of 135 degrees would be the same as the sine of 45 degrees, but we have to make sure the sign, the SIGN, is correct. So the sine of 45 degrees. Okay, we should know this exact value. You can go back to what I call the summary sheet, and if you haven't studied these, this is right in the middle of the page. Okay, it would be a good idea, as I've told you before, for you to learn the sine, cosine, and tangent for the 30-degree, 45, 60-degree angles. Okay, you will use these here as you're working out your problems. So the sine of 45 degrees is the square root of 2 over 2, or you could figure it out with the unit circle if you wanted to. So square root of 2 over 2. Should it be positive or negative? You always have to ask yourself. Okay, it's going to be positive because my angle is in the first quadrant, and so that lets me know that the sine of 45 would be positive. This angle is in the second quadrant, and also sine is positive in the second quadrant, so it's positive square root of 2 over 2. Okay, if I look at B, the cotangent of negative pi over 3. Well, first, if I want to find my reference angle, I'm going to have to find a coterminal angle since this is a negative angle. Alright, so first thing I'm going to do is take negative pi over 3 and add 2 pi. Okay, so I'm going to go ahead and write that as 6 pi over 3 with a common denominator. So that's going to give me 5 pi over 3. Remember, this is my coterminal angle. If I want to find my reference angle now, where is 5 pi over 3? It's in the fourth quadrant, so I would have to subtract 2 pi minus 5 pi over 3. Again, get a common denominator, which would be 3, so I would have 6 pi over 3 minus 5 pi over 3, which gives me pi over 3. Okay, this is my reference angle. This is theta prime. So if I want to find the cotangent of pi over 3, okay, again, I know cotangent is the reciprocal of tangent, so the tangent of pi over 3 is the square root of 3, so the cotangent would be 1 over the square root of 3. And then, of course, we rationalize. So that would be square root of 3 over 3. Okay, what quadrant are we in? Well, negative pi over 3 is in the fourth quadrant, because remember your negative rotation. So that means cotangent in the fourth quadrant would be negative. So we have to attach the appropriate sign, and it would be negative square root of 3 over 3. Okay, on part C, the sine of 300 degrees, my reference angle first would be, what, 60? Because if I subtract that from 360, so I would be looking for the sine of 60. Then, okay, I know that the sine of 60, if I can look at the unit circle, back to the chart if you haven't learned these, the sine of 60 degrees is square root of 3 over 2. But what quadrant are we in? Since this is in quadrant 4, since 300 is in quadrant 4, that means that the sine of 300 would equal negative square root of 3 over 2. It's the same value as the sine of 60, but with a negative sign since it's in the fourth quadrant. Okay. Now on D, we have an angle 14 pi over 3. Again, this is greater than 2 pi. So if I want to find my coterminal, if I subtract 2 pi just one time, I'm still going to have an angle greater than 2 pi. So what I'm going to do first is subtract, let's try to subtract 6 pi, okay, because this is what I'm thinking. Okay, 14 over 3, if I change that to a mixed number, would be 4 2/3. So we could say this is 4 2/3 pi. So I know if I want to get a coterminal, what I'm going to have to do is subtract, actually just subtract 4 pi from it. So that would give me, if I take 14 pi over 3 and I subtract 4 pi, I'm going to write that in terms of a common denominator of 3. This would be 4 pi, so that would give me 2 pi over 3. So that's my coterminal angle. Okay, so now if I want to find my reference angle, I'm going to subtract this coterminal from pi. So my reference angle would be pi minus 2 pi over 3. So that would be 3 pi over 3 minus 2 pi over 3 would be just pi over 3. So I'm looking for what would be the tangent of pi over 3. Okay, again, you could go to your unit circle. The tangent of pi over 3 is the square root of 3. This is in quadrant 2, so that means I would have to have the negative sign, because in quadrant 2, tangent is negative. Okay, and then finally E, we have negative, the secant of negative 17 pi over 4. Okay, again, if I want to get my coterminal angle, 4 will go into 17, 4 1/3, so it would be negative 4 1/3. I'm going to have to add 6 pi to this. Okay, so if I add 6 pi, I have negative 17 over 4, plus 6 pi would be adding plus 24 pi over 4. And so that would equal 7 pi over 4. Okay, what quadrant is that in? That's in the fourth quadrant. So my reference angle, I would subtract 2 pi minus 7 pi over 4. So this would be the same as subtracting 8 pi over 4 minus 7 pi over 4. The reference angle would just be pi over 4. So the secant of pi over 4 is the reciprocal of the cosine. So the cosine is the square root of 2 over 2. So the secant is 2 over the square root of 2. And then we rationalize. So 2 square roots of 2 over 2 would just be the square root of 2. Okay, so is it going to be positive or negative? We say the secant of negative 17 pi over 4 would be a positive square root of 2 because of our quadrant that we're located in. It would be a positive.